Hi folks, this is Chapter 1 lecture. Let me go over with you some of the key things you need to read about Chapter 1 in the book. A few important things with it. If when you're reading the chapter, do keep keep in mind these PowerPoint slides by no means replace your reading. They're just basically highlights of what key things that you need to focus in your reading with it. And I will point out key aspect of things on what you need to know for the exam and what you need to study for as well. I have this is 5th edition books slides we're using it for. So this is chapter 1 in any programming books that you look into. They all start out with is just a brief what is computer programming and what all this is entailed about this thing. So if you look at, I'm not going to read through each one of these slides to you, but it's basically an introduction to what is Java, like when you had 1436 with me, is what is C++ back then with it, and how does it actually fits in the whole criteria with this thing. I'd like for you, this is the third slide, just key things about, I'd like for you to know Java was built and developed by Sun Microsystem. I'd like for you to know that. That's very important. There are things I need for you to understand that Java has been around for much long time before C++ with it, and Java's been around in the appliance world with it as well. So these are the type of stuff that the nice thing about I'm going to talk to you about Java is that it has what you have the source code. You compile it in the platform that you're building it in. It creates the class file, and that class file, if you already understand what the class file works with it, you can basically compile it in your, if it's an Apple system, it will run on the Apple. If you're compiling in a Ubuntu Linux system, it's going to run in that, and you compile it in a Windows operating system, it's going to run in that. So Java is very versatile in things that you are using with it as well. So I'd like for you to know that it's developed by the Sun system with it as well. One of the things that when you look into computer, and in every profession now that I know needs to have a computer. Whether it is an accountant, whether they're an engineer, whether they're mechanics, whether they're a nurse, any one of these professions that are out there, they all have to use some sort of computer. And the nice thing about the computer is that it allows you to customize and program to fit what the skills that that's needed for that profession with it. So it does a lot of customization of, that's the power of the computer. That's where you learn is the program. You tailor to the needs of the individual that needs to be used with it. So what is computer programming? Computer is actually an art. There's two sides in computer. There's an art side and there's a science side. The art side is the creative side. This art side is where you get to program and be used to bring in asset files. You do different types of loops, different type of design. That's the art side with it. But there's also a science side. The science side is that you compile, it works, and you move forward. It's very black and white, very objective with this thing. So there is an art and science side for that as well. I'd like for you to know that as well. What's another term for a computer program? A computer program is another term is software. And that software is being used that you could actually develop software, in other words, for application software. These are the type of stuff that you will see that's going to be used in synonyms with it as well. So cross-platform, it means that you can actually take in various operating systems with it as well. One of the things I would like for you to know, in a typical computer application with it, there's what's called an application, and there's what's called applets in here. All right, there's various languages out there with it. You hear what's called JavaScript. JavaScript is not the same as what we're running here. What we're running here is Java application. So what you install is the Hello World. That is the Java application. You've developed different type of apps with it as well. So why do you program? Again, is to help you and your work to be a lot easier in the things that you do with it. And the key thing is I want to point out here at this point is that everything you do here, like I mentioned in 1436, is it's all about memory management. everything that you do in programming is about memory management. You are maintaining the RAM memory. And I want to ask you that on the program, on the exam, of course. When you program, you're basically giving a set of instruction that you're storing in the RAM memory. That is your computer temporary memory with it. And the other word I want you to think about RAM memory is it is volatile, meaning that when you shut down the computer, it wipes everything off. All right. So there are a lot of times in the computer, in troubleshooting, you would ask the user to shut down the computer so they would actually wipe off everything in the memory with it. There are various programs, as you can see here. There are spreadsheets, database, word processing, games with as well. If you ever get a chance to take a game class with me, I hope you do. That is, you're going to be developing a lot of games with it. Computers are very versatile because they can be programmed. This is a program. This is, I like for you to know this one. This is a test question right here. So computer programmers implement programs to perform a specific task with this as well. So when you look at why do you program? Well, one of the things is you get program is, again, it's tailored. It's like you don't want to buy a suit off a shelf that doesn't fit you. You want to buy a tailor suit that gives you the proper dimension and tailor that fits your needs with it. So program, when you actually start to program, there are things that you analyze, you experiment, you correct, and you redesign. So these are the type of stuff that you will repeat over and over again with it until you move from a beta version to an alpha version. Software will always be a beta version, just to let you know. There's always room for improvement with it. Programming language have strictly rules such as what's called syntax. Syntax are things that are punctuations, closing and opening, beginning and ending, capitalization, reserved words. These are syntax to every programming language that you have with it as well. I'd like for you to know this one. This is the major hardware component of the computer. There's the CPU, the main memory, secondary storage device, input-output with it. So I'd like for you to know that the CPU is where it has, actually, I'm going to talk to you about, there's two parts in the CPU that I would like for you to know. There's what's called the ALU and the central processing unit. Alright, so those are the two parts with it. The main memory is also known as the RAM. Your storage, secondary storage devices such as your C drive is where you actually put your operating system on there as well. They don't mention it here, but there's also the third one. It's called your BIOS. You don't have, that's your basic input system with it, or what's called your firmware. You don't have access to that. That's something that's actually the manufacturer has access to that when they actually roll that out with you. Very rarely you get access to the firmware and you update that. For the most average person, you don't know about that really with it. But key things I want you to know. Let's go back to the secondary storage. If I mention anything to you about like a hard drive, a floppy disk, or a USB drive, all of these are considered as a secondary storage. I'd also like for you to know that when a computer runs a program, the CPU engages into a process formerly known as what's called fetch, decode, execute cycle, and which is very similar to this process right here. And why do we program with it? Again, it goes fetch, decode, and execute. You're going to see this more prevalent as we come across and see when you start to program in this thing. When an operating system, when you take the operating system and when you look at, oh, here it is, the two things about the, make sure you know that there's the ALU and the C and the control units with it. The ALU cannot, just FYI, cannot calculate the remainder, so you have to do a mod function. Remember that I mentioned it to you in 1436 with it. When you come down and take a look at the, here's the fetch, decode, and execute. I'd like for you to know this. This is very important. How, when the computer program runs, what happens when you compile? It goes from the fetch, decode, and execute. So what does this mean? The CPU controls the unit fetch from the main memory. Next instruction is the sequence of program instruction, and then it gets to decode it. The instruction is formed into a number, bytes, and we hear zeros and ones with it. It generates combinations of these different types of zeros and ones, giving a translation to that as well. The signal is then routed to all appropriate component of the computer, such as the ALU, a disk drive, or some other device with it. So some sort of instruction that outputs to the screen. All of these things happens very, very, very milliseconds with as well. Let's focus on the main memory. This is what the RAM, random access memory with is currently. That's what houses. If you look at your system tray, the bottom right corner of your monitor, it shows you these are things that are running in your RAM. If you look at your taskbar at the bottom shows you what is actually being run during your computer being running with this thing. So the RAM is divided into units called bytes. 1 byte is equal to 8 bits. I'd like for you to know that with it as well. So so I'm going to ask you what's a byte? B-Y-T-E-S, not a physical byte like B-I-T-E, but a byte, computer byte. So it's equivalent to 8 bits. I'd like for you to know that, please. And I'm going to ask you what's the definition for a programming language with it. So it's a special language that's used to write computer program. Whether we're writing this in Perl, whether we're writing this in C++, Java, or any programming language, there has to be some sort of communication from higher level to lower level with it as well. One more thing, going back to this first couple of slides, on the top, I'd like for you to know that who actually made what's the original name of Java with this thing. So the original name of Java was actually called Oak. Okay, Oak. I skipped that slide. It's called Oak. Right here, Java. The first name, Oak, was developed for this purpose. So O-A-K. So I will ask you that. Make sure you know that. I'd like for you to know what's a syntax. Okay, that one slide shows the syntax with it. So what is a syntax? And I mentioned to you, syntax are things that are what? There are punctuations, reserved words, capitalization. These are the different syntax that you have. So make sure you know what a syntax versus something that's called semantics. Now I'm not going to semantics the meaning of each of the instructions that you actually ask with as well. So that's that with it. I'm sorry I'm skipping around here. But let's come down to this slide. This is where we left off with it. So what is a computer on and off? 1 is on, 0 is off with it. And the key thing is, I want you to understand is that what happens, so each byte of memory is assigned to a unique number known as an address. This is a memory address with it. So what actually takes place? Well, memory addresses is in the RAM. And each one of these memory addresses, the physical memory address, is in hexadecimal, which is very difficult for us to remember to know. But if you're assigning something like a data type such as an int x, and you assign it to it, there's actually a physical memory address that goes to it. The other piece is that I like for you to make sure you know that RAM is volatile, which means that when the computer is turned off, this entire RAM is erased with it. So this is something that is that is made sure that you turn off, and it just wipes off the buffer memory with it as well. I'm going to come down here and we talk to you about what's a byte. I mentioned to you a byte is 8 bits on here. This is the left hand side, is the hexadecimal side of this thing. Alright, that's the hexadecimal side of this. Let me check how many minutes I got here. Let me pause.